Hi, sixth graders. Today we're going to be working on a problem related to volume that's actually an enrichment problem, meaning it takes things a little farther than maybe you would see in your homework or even on your test. But I think as you watch this video and follow along with my work, you'll be able to apply principles to what you'll be doing when it comes to volume of three-dimensional shapes like this prism here. In particular, A will be something like a problem you'll be expected to know how to do. But as we continue on into B and to C, you can just observe the calculations and the various mathematical concepts I'm pursuing, and hopefully you get a lot out of this. Let's start by reading this together. A swimming pool is 60 yards long and 30 yards wide. The depth at the shallow end is 3 yards, increasing uniformly to 6 yards at the deep end. Water is pumped into the pool at a constant rate. It takes 3 hours to fill the pool completely. Find the volume of water needed to fill the empty pool completely. Well, to start out, finding the volume of water needing to fill this pool means we need to find the volume of this prism. Now, it looks at first glance like it would be triangular, but it's not. This doesn't come to a single point. It comes to 3 yards. So what does that mean? Look at it sideways if you need to. There are 2 parallel bases and then other sides that are not parallel. So the bases that are uniform, that we could take cross sections from of this prism, are trapezoids. So our formula for the volume of this prism is going to be the area of one of these bases, or a cross section, which is the area of a trapezoid, times the height of the prism. So we have our game plan written out here now, what we're going to be trying to do as we solve this part of the problem. That's just our formula for finding volume, the area of this base or area of a cross section times the height of the prism. Now, the height of the prism in relation to the 2 bases is actually going to be this 30 yards right here. Because if we're assuming these 2 sides are bases, then this would be the height. Hopefully I indicated that as best as I could, and you can tell that this 30-yard side is going to be the height of the prism if we're calling the bases the trapezoids. So that's going to be 30. And the formula for area of a trapezoid is, hopefully you're remembering, 1/2 times, parentheses, base 1 plus base 2 times the height, or base 1 plus base 2 times h over 2. Either one works. Dividing by 2 is the same as multiplying times 1/2. And we're going to multiply that at the end by 30, so we're just going to keep bringing this down. Pardon me. All right, so our 1/2 stays the same. Our base 1 is 3 yards. Our base 2 is 6 yards. Just because they're small numbers doesn't mean they're not there. This is one base, and this is another. And our height, as we said, the height of the prism is 30, but the height of this particular trapezoid is what? 60 yards. And then at the end we'll multiply by the height of the prism. Great. Let's continue bringing these numbers down and solving. 3 plus 6 is 9. So 9 times 60 would be twice as much as 9 times 30, because we have that 1/2 in here. So we're going to have this is a 270 and multiply it by 30, which is the height of the prism. So as we trace this down, we see 270 yards squared is going to be the area of the trapezoid times the height of the prism. And when you do that, you can go ahead and do that calculation, but you'll get 8,100 yards, what for the volume? Cubed. That's the volume of this prism, which means it's the volume of water needed to fill the empty pool completely. Great job. That's something that I would expect you to be able to know how to do. Let's take things a little further. Find the time it takes to fill the pool to a depth of 3 yards at the deep end. All right. We're going to have to be kind of going back and forth because my camera won't show the whole page at once, but that's all right. So if the deep end, when it's completely full, is 6 yards, that means when the deep end is half full, it's going to be 3 yards. And 3 yards is actually the depth over here. So we're going to have a different type of prism with a triangular base now. So we're going to do the same thing we did up here to find the volume before we find the time it takes to fill. So now instead of volume equals a cross-section area of the trapezoid, we're going to take it of this triangle. Area of a triangle times the height of the prism for volume. All right, and the formula for area of a triangle is base times height over 2, or 1/2 times base times height. And the volume of the prism is still 30. Now our base of this triangle is going to be 3. And the height is going to be 60. Do you see that? That long length there is 60 yards. So we're going to have 3 times 60 divided by 2. And we'll multiply that times 30 at the end. Do not get the height of the triangle here confused with the height of the whole prism. All right, so 3 times 60 would be 180 divided by 2, which would give us 90 times 30 equals 2,700 yards cubed. But we haven't found our answer yet. 2,700 yards cubed is the volume of this lower area. They want to know the time it takes to fill the pool to a depth of 3 yards at the deep end. We can figure this out by simply using ratios. We know the total volume now. We found that in our previous part of our problem. And if we go back up and read the intro, it tells us it takes 3 hours to fill the empty pool completely. So I'm going to do a ratio for 8,100 yards cubed. We take 3 hours to fill it. Now we want to find out how much or how long it takes to fill something that is this volume that we just found, 2,700 yards cubed. Remember these? These are ratios. Well, they were very kind to us. These are related by a factor of exactly 3. 8,100 divided by 3 is 2,700. You can kind of think about it without the zeros if it helps you. So divide this by 3 to get this number here. And in ratio, we would divide 3 hours by 3 to get 1 hour. Excellent. So that is our answer. Find the time it takes to fill the pool to a depth of 3 yards at the deep end. To fill it to this volume, which is what it would be if the depth was that at the deep end, would take 1 hour. All right, great. Now let's move on to the most challenging part of all. Find the depth of water at the deep end after 2 hours. Now I'm gonna kind of draw a sideways view of our pool here to give a visual explanation of this one. Our pool has a slanted bottom, right? And it says it is increasing or decreasing uniformly, so we know it's just a direct diagonal line here. It doesn't have any wiggles or steps or jumps. And we know that this is 3 yards and this is 3 yards because they tell us at the top that the deep end is 6 yards. And we already found the volume of, imagine this is three-dimensional, this lower part of the deep end, because we went to the 3-yard point up here, the halfway point. Now, think about this. This area, if this was two-dimensional, would be half of this because they have the same base and height, but this is a triangle and this is a rectangle. In the same way, the volume of this part of the pool is going to be half of that of this part. Now, we found out from this problem that to fill up just this triangular part of the pool will take 1 hour for the 3 yards to fill up. But this is going to fill up twice as fast as this because there's half as much volume. So for this part of the pool, the upper part, I know I've divided it up here, but we're really just talking about the top part of the pool versus the bottom part of the pool. For this to fill up in 1 hour, it will only fill up 1.5 yards because it has more area, or more volume rather, to fill up in this rectangular prism than in this triangular prism. Exactly twice as much. So if it's the same amount of time, it's going to go up only halfway. All right, hopefully this is making sense. They want us to find the depth of at the deep end after 2 hours. Well, after hour 1, we already found that in the previous part of the problem. We would have 3 yards of the deep end. And then after hour 2, we would be adding on the 1.5 yards to get a total of 4.5 yards. The deep end has water that is as deep as 4.5 yards after 2 hours of filling up this shaped pool. Wow, what a really cool problem that you guys were able to follow along with me. Hopefully you can try this on your own if you'd like, by not looking at my video and my steps, and then maybe come back to the video to revisit it and make sure you've done all of your steps properly. But I really enjoyed working on this problem. This took me a while to solve on my own before I even began the video, so don't fear if it takes you a while to kind of wrap your heads around some of these concepts. What I want to make sure you definitely understand for sure is how you would just find the whole volume of this pool. Thanks for tuning in today. I'll see you soon, virtually.